Hey everybody, it's Larry. I'm doing day 10 of the Leetcode daily challenge. Hit the like button, hit the subscribe, and join my Discord. And let's look at today's problem. Minimum number of hours to burst balloons. Okay. Horizontal X. Okay. So you're trying to minimize the number of hours that could be shot to burst all balloons. Okay. So it seems like some variation of um, scanline algorithm where we parse the events. And I think in this case, what you want to do is greedily um, only look at the exit event, because on an entry event, you want it to be greedy as possible. Because basically, I think that's my thing is that why is it greedy? Well, each balloon has to be shot once, and and we want to make that as greedy as possible because we have shot once anyway. Then yeah, we want to shoot as late as possible. So let's kind of give that a try. Hmm. Computer's acting a little slow. Okay. Hmm. Technical difficulties. Hmm. Okay. So for start, oh, let's go for now my browser came back for bottom top endpoints. Let's just do events, and we have to append. We want to append the bottom because we want to go from bottom to one, and we do +1 by +1 explicitly, and then events dot append top -1, right? And then what we want to do is just price sort the events. Yeah, and then now for I don't know, X, I guess in this case it is action X, and then delta in events. If delta is equal to -1, that means that we're at the end of a segment. Then we want to shoot everything that's in it, right? So let's actually have um, yeah, let's actually have count is equal to 0. If this is the case, let's do count is equal to let's increment count. And what we want to do is basically have basically we want to keep track of all the set that is done. Right? So let's just say let's just keep track of inset is equal to set, and then we want to make it so that if delta is equal to 1, we actually want to insert this to the set, insert this segment into the set, right? And we have to keep track of, in this case, the index. So let's actually add that here. So I just woke up, so like stuff is a little bit wonky, and my setup is not good today. So I apologize for that. But yeah. So then now here we have index as well. So inset will add index, and hmm, and in here we want to just make sure that okay. So I think what I want to do is have two things, right? I just have a done set. So then here we just done. We add the inset, so every element in the inset is now in done. And then here let's just say we only process this part if index is not in done, right? I think that should be good enough. It looks a little bit wonky, but that's how greedy algorithms is sometimes. Let's give it a quick run. Let's copy and paste all the answers. Ooh, I have a typo. Oh, whoops. Let's give it a run while we go up and copy and paste some more. Oh man. Oh, I need to turn that into a tuple. That's okay. That's easy. Copy and pasting is slow. My computer is really weird today with my browser Chrome. But that's okay. Hopefully okay. We'll see what happens. And yeah, we just have to switch this to a tuple, which I made a silly mistake on. Let's run the code. And ooh, I thought you could do that, but maybe it's this. That's what I meant. Don't remember the syntax for adding. Okay, so it looks except for this one. Why is that? Oh, I see. It's because the two overlaps, and we wanted to. So we want to greedy on overlapping as much as possible, right? So in this case, instead of -1, +1 and -1, we actually want to sort the +1 first. So let's change how we sort a little bit. But x sub 0, x or -x sub 1, so we reverse the order of the second one. I think that should be okay. We don't care about the index order, so yeah. So that looks greedy because in this case, we put the second two first, so that when we burst it, because as we do, we only burst on the -1, meaning the end of a segment. We want to count inclusively all the segments that are in it, right? So let's kind of give it a submit. And then we'll go over the complexity. Cool. Yeah, so what is the complexity, right? So actually, you can show that given this for loop, and I know that this actually is a for loop as well, because you're taking every element from the set and put it into another set. So this looks pretty wonky, but this loop is actually only O of n, because each element is only inserted into inset once. Each element is only inserted into done once, and you only look at each element once in the event, right? So it's going to be O of n here. And of course, it's sorting, so it actually ends up being O of n log n. And there'll be 2 times n events. So n log n time, linear space, greedy scanline algorithm or sweepline algorithm. Yeah, that's all I have for this problem. It's actually kind of tricky, as greedy problems usually are. Definitely play around with the ideas and figure out why. Like for example, why you want to burst everything as possible. I think the thing about these segments is that allows you to be greedy is because when you make a decision, you always have to burst every balloon, right? So that given a balloon, you always have to burst it, and every balloon that you tie with it, it makes sense to kind of do in a very greedy way because there's no once you go from left to right in a scan line, and you go past a balloon, there's no way to go back, right? So you can't be like, oh, I'll just save this balloon to be burst later, right? So in that way, you have to be burst at the latest as possible, and that's how I solved this problem. Let me know what you think. It's a little bit wonky, a little bit hand wavy. I'm a little bit not 100% set up today. So let me know what you think. I will see y'all tomorrow. Bye bye.